So we're going to work on adding and subtracting. That's the idea of putting these sets in brackets and having an addition or subtraction sign. Polynomials, which is just a set of terms. So we have this expression here. And this expression states, according to BEDMAS, we deal with our brackets first. So it says 3y plus 5 added to 7y minus 4. Okay. According to BEDMAS, we deal with brackets first. Can I simplify in the first set of brackets? Why not? They're not like terms, right? This is a constant, while this is a variable of y. There's nothing to collect in there. Same with our other bracket, okay? There's nothing to do. But what I want you guys to realize is, first of all, if there's no operation written in front of something, what do we assume it is? Assume it's a positive value, okay? So think of this like a positive set of brackets added to another positive set of brackets. Now, we need to drop these brackets, and this can be confusing. We're going to go into a little more depth in its moral, but we can use something called distributive property. This is a positive, but there's no value here. Okay? If there's no value there, we're going to make an assumption of a number 1. Okay? And you'll see how this will help us. Positive 1 beside a bracket means to multiply. So I want you to take the idea of multiplying positive 1 by both terms inside the brackets. Okay, now this might seem confusing. What will positive 1 times 7y be? Positive or negative? That's very important. Positive 7y. And what is positive 1 times negative 4? Still negative 4. Great. So those terms never change. They're the exact same. And our other terms are 3y plus 5. So because I did this, which is known as distributive property, and we'll get into more and more, I've now eliminated the brackets. Now without those brackets, I can collect my like terms. What are a pair of like terms here? Scott?
3y and 7y.
Yeah, those are like terms. Both of the y's are to the power of 1. Any other set? Scott?
Positive 5 and negative 4.
Great. So those are our like terms. Now, if it's hard for you to see because they're split up, we can move like terms beside each other. I'm going to take the 3y and bring the positive 7y beside it. As long as I keep the operation in front of both of them, that's more than fine. Same with positive 5 and negative 4. I can move them beside each other as long as I keep the operations in front of them. Once I've done that, I can start to collect the terms. So what would, and let's not really focus on the y. We know our answer is going to have the variable y, but let's focus on the two coefficients. What's positive? Because if nothing's there, we assume it's positive. Positive 3 plus positive 7. 10. So we have positive 10y. And what is positive 5 minus 4? Positive 1. Yes, Windows Basic, please. So our answer is, and it's already written there, I'm just going to write it all in one color, is 10y plus 1. That's when we've collected all our like terms. So let's move into something that might be a little more challenging for us. Okay, in this one here, same idea. Let's think of BEDMAS. Can I simplify this bracket at all? Why not? What about this a and this a? That's right. They don't have the same exponent. Technically, there's a power of 1 here. So this, and this aren't like terms. I can't simplify anything in that bracket. And the same idea happens here. Now, the reason I showed you that funny-looking distributive thing is because it's going to come in very handy when it's a negative term. You noticed when it was a positive up here, the terms didn't change. But if we have a negative in here, I want you to think of the idea of this being a negative 1 multiplied by all 3 of these terms. And that's going to change things for us. Okay? So the first set of brackets, there's nothing here, so we just leave it. Whatever the terms are, we have the same one. So we have a squared minus 2a plus 1. What would negative 1 times negative a squared be? That would be positive, right? In negative times a negative, it'd be positive a squared. So the value of the term doesn't change, but the operation did, which is the negative or the positive in front of it. So same idea, negative 2a times negative 1 would be what? Positive 2a. And negative 5 times negative 1 is positive 5. Okay, so we've now gotten rid of all of our brackets, so we can start to collect whatever like terms we have in this question. So, can anyone point out a pair of like terms for me? Right.
The a with the exponent.
The a squared, sure. And the a squared. Excellent. Good. So we're going to bring those two together in a second. Another pair. Scott?
Negative 2a
Yeah.
and positive 2a.
Great. And finally, someone else.
One and 5.
1 and 5, the constants. Great. I've highlighted them so we can put them together as a pairing. Okay? We usually put the pair with the highest exponent first, so I'm going to put our a squared plus our a squared. And this is an excellent example of something that has no coefficients in front of it. We have to figure out what to do with it. Okay? The next set I'm going to put together are our, and remember this operation is very important, negative 2a and our positive 2a. Those are the two that we highlighted in green. We've just moved them beside each other so visually it's easier for us to solve. And finally, we have positive 1 plus positive 5. You don't have to reorder when you guys go through this, but sometimes reordering them, so putting them beside each other, is simpler for us to see. Now, in this question, what coefficient is in front of both of these a squareds?
1.
A 1. There's technically a 1 in front of both of them. So really, the question is asking, what is 1 plus 1? 2. And then what do we attach to the end of it?
A squared.
A squared. So we've simplified the yellow. It's now only one term. Okay. And our other one, what is it? Negative 2 plus positive 2? 0. So I can add or subtract 0. It doesn't make a difference. Okay. So I'm going to say 0a. That's the simplified version of our greens. And what is 1 plus 5? 6. So we have all of our numbers together. Now I can write the answer this way, but there's one of the terms I don't really need to include. Which one do I not need to include? The 0. We know 0 times whatever this number is. A stands for an unknown. Whatever it is, it doesn't matter, because 0 times it will essentially equate to 0. So really we can write this as 2a squared plus 6.